Hello students, welcome to the online class for automobile component design. This subject is present in your 5th semester diploma syllabus for automobile engineering department. Let me first introduce myself. My name is Tanmoy Kundu, assistant professor, Department of Automobile Engineering, Dr. Sudhir Chandra Sur, Degree Engineering College, Kolkata. Come to the course objectives to impart knowledge of fundamental concept of machine design applied to automobile components, to impart exposure to standard course of practices, CAD and use of design data book, to impart knowledge concerned to automobile component design. Next come to the course outcome. So at the end of this course students will be able to analyze, identify and use these following important course outcomes. So next come to the lesson plan. So this lesson plan for this subject is prepared as per the syllabus provided by the West Bengal State Council. Now in this lesson plan the module number 1 and module number 2 I have already covered. So today I shall discuss the different design methodologies for the piston ring, that is module number 3.5. So topic is piston ring design and lecture number 26. First of all we have to know what is that piston ring. Now these piston rings are used to impart the necessary radial pressure to maintain the seal between the piston and the cylinder bore. Okay, so rings are basically act as a sealing arrangement, sealing material. Okay, so any particular leakage of the gas should not be allowed, okay, through the cylinder wall. Okay, so that is why these rings are used as a sealing material and to provide the sufficient radial pressure to maintain the seal. Okay, these piston rings are usually made of grey cast iron or alloy cast iron because of their good wearing properties, and also they retain spring characteristics even at high temperature. Okay, so this is important thing why we have chosen grey cast iron or alloy cast iron, because they have the superior qualities like good wearing properties and a behavior like spring even at the higher temperatures. Okay, the piston rings are following two type. One is that compression ring or the pressure ring, another one is the oil control ring or oil scraper. Okay, so these are basically two types. So pressure ring or compression ring and another one is the oil control ring or the oil scraper. Okay, now these compression rings or the pressure rings are inserted in the grooves at the top portion of the piston and maybe 3 to 7 in number. So you can remember that in the previous lecture, okay, perhaps it was lecture number 23 or 24, where I have shown you the different types, I mean the different you can say that basically that is the trunk type piston. When I have discussed the trunk type piston diagram, so in that case I have shown you that in the cylinder here we see that these are the portions where these particular rings are provided. Okay, this way. Like this, these items are not there. So these are the space provisions where the rings are provided. Okay, and the compression rings are from the top. If you see that from the top, the part one groove, group number 2 and group number 3 are for the pressure rings, and last grooving was provided for the oil control ring. So you should refer that particular lecture for the where is the diagram for the trunk type of piston is provided. So in that case you should notice that diagram. So So these compression rings or pressure rings are inserted in the grooves at the top portion of the piston. So and that may be in 3 to 7 in number. So here I have shown you 3 in number, where in the case of trunk type piston 3 numbers are provided, 3 numbers of groovings are provided for the compression rings. These rings also transfer heat from the piston to the cylinder liner and absorb some part of the piston fluctuations due to the side thrust. So you can understand the importance of those compression rings. First importance is that it can transfer the heat. Second is that the piston fluctuations due to the side thrust can be accommodated by this particular compression rings. Then come to the oil control ring or the oil scrapers. So they are provided below the compression ring. Okay, so they, as you see that this group number 4 is for the oil control ring. So the oil control ring or oil scrapers are provided below the compression rings. These rings provide proper lubrication to the liner by allowing sufficient oil to move up during upward stroke, and at the same time scraps the lubricating oil from the surface of the liner in order to minimize the flow of oil to the combustion chamber. So basically this act as a oil treatment process, or you can say the oil it can be oil flow is completely controlled by with the help of this particular oil scrapers. Okay, so controlling as well as the scrapping, so both these two activities are performed by these rings. Okay, so once again I am telling you that these rings provide proper lubrication. So first one is that these oil control rings provide the lubrication to the liner by sufficient oil to move up during the upward stroke. Okay, so when there is the upward stroke, like from movement of the piston from BDC to TDC, in that case it helps as a supplier of the oil to to maintain the system under complete coverage of the lubrication. Okay, now this is the control of the oil control process. Another one is the oil scrapping process. So at that time at the same time scraps the lubricating oil from the surface of the liner in order to minimize the flow of the oil to the combustion chamber. So you can understand that it behaves like a scrapper as well as the controller of the oil. Okay, the compression rings are usually made of rectangular cross section, and the diameter of the ring is slightly larger than the cylinder bore. Okay, a part of the ring is cut off in order to permit it to go to the cylinder against the liner wall. The diagonal cut or step cut ends as shown in figure 1a and 1b respectively. So here we see this is figure A and figure B. So this particular gap is provided. This is the diameter. Even the diameter is more than the cylinder bore. Okay, so this is diagonal cut and this is step cut. Okay, this is diagonal cut, this is step cut. Diagonal cut means this cut is provided, this cutting is provided diagonally, and this is step by step cutting, so it is called as the step cut. The gap between the ends should be sufficiently large when the ring is put cold, so that even the highest temperature the ends do not touch each other when the ring expands, otherwise there might be buckling of the ring. So this is the gap, and why this gap is provided? Because of the higher temperature, when the ring material will try to get expand, so what will happen? If no gap is provided, so at that time after expansion due to high temperature, the buckling phenomena or bending phenomena will occur in the ring. Okay, in the piston ring. So that that has to be prevented, and in order to prevent that phenomena, prevent that buckling phenomena, this particular gap is provided. That is, when at the higher temperature also, when the material gets expanded, so this particular gap will be accommodated. Okay, this is diagonal cut and this is step cut. The radial thickness, that is T1 of the ring, may be obtained by considering the radial pressure between the cylinder wall and the ring. From bending stress consideration in the ring, the radial thickness is given by, so radial thickness value like T1 square equal to D of square root of 3 PW divided by sigma T. So T1 means it is the radial thickness, and that is provided in millimeter unit. So where D is the cylinder bore in millimeter, PW is the pressure of gas on the cylinder wall in Newton per millimeter square. Its value is limited to 0.025 Newton per millimeter square to 0.042 Newton per millimeter square. So that value we have to remember, PW value, because it may not be provided in the question as well. Okay. What is sigma T? So sigma T is the allowable tensile or bending stress in MPa. So its value may be taken as 85 MPa to 110 MPa for the cast iron rings. Okay. The axial thickness T2. So T1 is the radial thickness and T2 is the axial thickness. What is that radial thickness? As you know, the thickness across the radius, that means this one is the radial thickness, and this particular thickness from top to bottom, so this thickness is called as the axial thickness. So this axial thickness of the ring may be taken as 0.7 of T1 to T1. That means it should be 70% to 100% of the T1, that is the radial thickness. Okay. So axial thickness value we have to remember, T2 equal to 0.7 T1 to T1. The minimum value of the axial thickness, that is T2, may also be determined from the following empirical relation, that is T2 equal to D by 10 NR. So NR means number of ring, okay, depending upon the number of ring. So as you see, when the number of rings are less, so in that case the T2 value will be more. When number of rings are more, so T2 value will be less. So from this expression also we can determine the minimum axial thickness value. The width of the top land, that is distance from the top of the piston to the first ring groove. As you know, once again I would like to refer you to follow the trunk type of piston diagram that is provided in the lecture few days back. Okay. So perhaps it is lecture number 23 or 24. Please refer that particular diagram for the trunk type of piston. Here also that is mentioned the what is top land. Okay. So top land is nothing but that is top of the piston, from top of the piston to the, like this, if it is the grooving. So from top of the piston to the first groove, the height is called as the top land. Okay. So distance from the top of the piston to the first ring groove is called as the first land. So this width of the first land is made larger than other ring lands to protect the top ring from high temperature connections, consisting at the top of the piston. So that is the thing. From high temperature conditions existing at the top of the piston. Okay. So that is the thing, that this first width of this top land should be made larger. Okay. So therefore width of the top land, it is denoted by B1. Once again refer that diagram. So in that diagram also B1 is completely notified in that trunk type of piston diagram. So B1, length of the B1 should be TH to 1.2 of TH. So TH means, as you know, it is the head thickness. Okay. So B1 shall be TH to 1.2 TH. The width of the other ring lands, that is the distance between the ring groups. So distance between the ring groups, like this. Okay. So distance between these ring groups of the piston may be made equal to or slightly less than the axial thickness of the ring. Okay. Slightly less than the axial thickness of the rings. So these are the different statements to be followed as a design methodology for this particular component. Therefore, width of the other ring length shall be B2 equal to 0.75 T2 to T2. Okay, T2 means it is the thickness, axial thickness of the ring. Okay, so that is B2. The depth of the ring group should be more than the depth of the ring, so that ring does not take any piston side thrust. Okay, so depth of the ring group should be made more than the depth of the ring. Okay, so group depth should be more than the ring depth. Okay, why it is more? Because the ring does not take any piston side thrust. Okay, so that the ring does not take any piston side thrust. Otherwise, if it will take the side thrust, so it may be damaged. So it should be completely protected from the side thrust. The gap between the free ends of the ring is given by 3.5 T1 to 4 T1. Okay, so gap between free ends. So like this gap, why this gap is provided, as I have told you earlier, this one is the gap. So the dimension of the gap should be like this. So it should be 3.5 T1 to 4 T1. The gap when the ring is in the cylinder should be like 0.002 to 0.004 D. Okay, D means it is the bore of the cylinder. So here we see this is all about the different types of design guidelines for the piston rings, and also you can notice that every particular dimension has some design data and design way. So of course you have to remember all those important data, important dimensions, because these relations, these empirical relations will not be provided in the numerical question. That is why you have to read it thoroughly and you have to practice those carefully. Okay, because unless and until you will not practice, or you will not chalk out those important points at your own handbook, so you will not be able to remember those. So that is why, depending upon the different types of material, different types of components, the design data are different types. Design data varies, and the empirical relations are also varying. So all the design methodologies, design guidelines, we have to adopt thoroughly. So you have to remember the function of the piston ring, the characteristic of a good piston ring, why grey cast iron is so suitable, or alloy cast iron is so suitable to for the piston ring, and what are the different types of piston ring, the classification of piston ring, like compression ring, like oil control ring, or oil scrapper. So what are their individual functionalities? Okay, what are the functions of compression rings, what are the functions of oil control ring, why they are so much important, and also in terms of like construction point of view. So as I have told you earlier that you have to refer the diagram for the trunk type of piston. Only then you will be able to understand those things, that what is B1, what is B2, all those things. Okay, top land, what is bottom land, all those things you will understand. So as I have not provided this diagram once again here, but you have your all those study material along with you. So please refer that study material where this particular trunk type of piston is depicted and it is represented. Okay, so along with this particular lecture or the study material, you have to follow this diagram as well. So here we see that the width of the top land, the width of the ring land, all those things are having some relations, mathematical relations with respect to T2 or TH or D. So everything you have to remember. Okay, the axial thickness of the ring, the radial thickness of the ring, how we can determine. Okay, so here we see that T2 can be 0.7 to 0.7 T1 to T1. Once again, there is another method to find the value of T2. Okay, so that is D by 10 of NR. Now among these two, so use these two relations to find out the value of T2. Now larger of these two will be adopted. Okay. So please go ahead with this study material and prepare those very well. So this is all about my today's lecture on the piston ring design, and in the next lecture I shall start with a different component of engine. Okay. So thank you very much everyone.